Hi, welcome to the video. So here we will tackle some basic concepts or knowledge regarding the integral calculus. So we have here the integral calculus. So first, let's define some terms. So for the definition, let's say for example, we have big letter f x. So the function of fx has a derivative of small fx. So function of fx. So the big letter fx or function of fx, the derivative is f of x. Okay, so we say that the f prime of x is just f of x, okay, on a certain interval of x-axis. So this is the derivative of fx. So we have this small letter f of x here. And then if we trace back and then we got the antiderivative or the of this fx, then we have this big letter f of x. Okay, therefore we say that the antiderivative of small f of x is just the big f of x. Okay, the derivative is f of x, and then the antiderivative of small fx is just big letter f of x. So by the definition, that is the simple explanation of the derivative and the antiderivative. It only means that the exact but opposite operation of derivative is antiderivative, or what we call the integral. So after the definition of the antiderivative or the integral, now let's have some notations that are usually used in integral calculus. Okay, on your integral calculus, this f prime of x here denotes the that you need to perform a derivative of some function, which results to this. But in integral calculus, the integral sign or the sign of integration is somewhat something like this curve. So this is the integral sign, what we call integral sign. So if in your differential you have f prime of x, so in your integral you have this sign. It looks like a small letter r that looks like letter x. So if you have the function f of x, in order for you to get the integral of this function, so this f of x here is called your integrand. So that is the what we call your integrand. This is that is the one that is being integrated. Okay. Then the result of this, if you integrate this function, of course you will get this one, the f of x. Okay, so that is your now what we call the integral. That is your integral. Okay, the result of integration of, or where you integrate some integrand or some function, then the result is the what we call integral. Okay, so you need to remember these notations. The integral sign means that you need to perform the integration with the function or your integrand resulting to your integral. So next we have another concepts. We have the sorry for the noise. We have the different types of integrals. So we have excuse me. We have two types of integral. Integral. So we have the what we called the indefinite integral, and of course we have the what we called definite integral. So by definition of this one, so our indefinite integral, by its word in, definite integral means it is an integral without limits of integration. So indefinite means there is no limit when we integrate the expression or when we integrate the integrand. Okay, so for say example, we have this expression f of x. F of x is equal to 4x cubed. Okay. So if we integrate this f of x dx, we can now have the integral which is equal to 4x cubed or x4 plus some constant 4 or x to the 4th plus 3. So all of these three expressions here can be the result when you integrate the function f of x at this. So all these three expressions can be the answer. Therefore, it is the what we call indefinite integral. So because there is no definite answer on when we integrate our function f of x. So all of these three can be the answer and many more answers. Okay. As you can see, they are both the same. X to the 4th plus some constant c, like what I have circled the constants of your integrals. Okay, so we can say that this indefinite integral here is just equal to x to the 4th plus some constant c. And then another notation, the plus c here is the what we call the constant of integration. Okay, so that is for the indefinite integral, means that there is no limit and you can have different integral functions, but not unique integral functions. Okay, so for the definite integral, this definite integral only means that it is an integral with limits of integration. So the result involves neither the variable of x or y nor the constant c. Therefore, you have the exact or definite value for your answer. Okay, you cannot see the x or the constant c, but you have the definite value or number for your answer. So for the definite integral of this function f of x, you can now write this as with integral sign, but of some function of your integrand f of x. But now for definite integral, we say that it has limits of integration. Okay, so we can now have the limits of integration for some integral of some function of f(x). Okay, so by the way, we can denote this answer as f of x plus some constant of c. Okay, so going back, we have the limits of integration. We have a and b. A is our lower limit, what we call lower limit, and b is our upper limit. Okay, so on our next video, we will have some examples, and we will tackle more about this indefinite and definite integral. So don't you worry, we will discuss it furthermore in order for us to really appreciate difference between the indefinite and definite integral. Okay, so by the way, if we perform this definite integral, and then we integrate this f of x dx with some limit from a to b, then it means that our answer or our integral has the exact value or definite value as an answer. Therefore, it has a definite value. Okay, so that is for your definite integral. So at this moment, all I want you to remember is that we have two types of integral, what we call the indefinite and definite integral, one without limits and one with limits of integration. So on other video, we will tackle more about this. So see you on our next video.